Okay, last question. This is question number 23 on page 426. So why don't you go give it a shot on your own? It is very similar to the boat and current question that we have already done, if you're watching these videos in order. So yeah, go give it a shot, see how you do, and then come back here for the solution. Members of a cycling club rode on the KVR trail uphill from Penticton. The uphill climb reduced their usual average speed by 6 kilometers per hour, and they took 4 hours to get to Chute Lake. On the return trip, the downhill ride increased their usual average speed by 4 kilometers per hour. The return trip took 2 hours. It's asking us, what is the average speed, the usual average speed of this bike club, and what is the distance from Penticton to Chute Lake? So here's what's happening. Here is Penticton. Again, guys, if you can draw stuff, it'll help you so much. Here is Chute Lake. This is the KVR trail. Okay? We know that the trip from here to here is an uphill trip. We know that the trip back is a downhill trip, obviously being quicker downhill. When they are traveling from Penticton to Chute Lake, it is more difficult, and going this way decreases their speed by 6 kilometers per hour. Going this way on the return trip increases their speed by 4 kilometers per hour. And by their speed, I mean their usual average speed as a bike club. We know that this trip from here to here takes 4 hours, and this trip from here back takes 2 hours. So this is what's happening. If you can kind of draw it out, get yourself an idea of what's happening, it makes this a little bit easier. So the two things it's asking us to find is the usual average speed and the distance from here to here. Keeping in mind that here to here is the only distance it wants, not the whole round trip distance, just the straight line distance from Penticton to Chute Lake. So let's go with, as usual, let X represent. Let Y represent. X is going to represent our first question, the usual average speed in kilometers per hour. Let Y represent distance in kilometers from Penticton to Chute Lake. Okay. So we've got our variables defined here. Now we've got to maybe write in some more. We've got all this information that I filled in up here in kind of a diagram sort of way. Now we have to come up with some equations, and this is very different from anything we've done, other than maybe the boat example. So what do we know? We know that it takes them 4 hours to go this way. It takes them 4 hours to cover this distance. So we know that it takes them 4 hours to travel a distance from Penticton to Chute Lake. What represents this distance? Y. Y is this distance. So something, all of the work that they are doing over this time is going to equal the distance Y. So what can we use to represent the time it takes to travel this distance? Well, we know it takes 4 hours at a speed of what? At a speed of their usual average, which is X, minus 6, because they are going uphill. So here's the equation. Let's see if this can make sense to you guys. traveling for 4 hours at a speed of our average minus 6 kilometers per hour because it's uphill. So 4 hours times miles per hour is going to give us this many miles. And that is true. Now, if that doesn't make sense to some of you guys, I want to show you just kind of a little trick that I use sometimes to think of this sort of stuff when it happens. You guys are going to be able to see this? Yeah, so up here I'll do this. 4 miles per hour is literally, miles per hour is, let's do this. This is 4 hours and is being multiplied by this much in miles per hour. And miles per hour, just so you guys know, when it's like written mph, it's actually miles per hour. It is a division statement, miles per hour. So what's happening here is I've got 4 hours over 1 multiplied by miles per hour. What is actually going to happen is these h's cancel out and leave you with just miles. So when you have something here, it looks like, whoa, this doesn't make any sense, Mr. Aaron. This over here is a distance. And over here, we're talking about times and speeds. How can times and speeds equal a distance? Well, because this is the math that is happening. You have a time, 4. This is just hours. And it's being multiplied by a speed, which is in miles per hour. So when you have hours times miles per hour, you can see this fractional math would become hm over h. The h's cancel out, and what are you left with? Just miles. So you have something that's miles equals miles. That's how this kind of works, just as a little thought trick for you. So this is one of our equations. One of our equations is that if we travel for 4 hours at this speed of miles per hour, normal, minus 6 because it's uphill, that'll give us the distance to Chute Lake. The next one, is very similar, except now we're talking about the return journey. So now that you have this one, it should be very simple. We know that, again, the return journey is still y. The distance has not changed. Chute Lake has not got any further away from Penticton, so it's still going to be equal to y. But now we're traveling for 2 hours at a speed of our normal speed plus 4, because we're going downhill. So our average speed has been increased. So all that this means is that, now we have our 2 equations, and we want to, convert them into some form that we can use elimination. So let's first of all get rid of the brackets by distributing inside here. So this one is going to become, 4x minus 24 equals y. This one's going to become 2x positive 8 equals y. So there's your 2 equations. Now, in order to use elimination, we want both of our variable terms on the left side and our constant term on the right side. So let's rearrange this one more time. This is going to be 4x. We need to subtract the y here to bring it over. Subtract y. And we need to add the 24 here to bring it over to the other side. So this becomes 4x minus y equals 24. This one down here becomes 2x, again, minus y equals, and now we need to subtract the 8 to get over here, minus 8. So there's your 2 equations. You can see that we have a negative y on top and a negative y on bottom already. So because of that, we don't need to multiply these equations by anything in order to use elimination. We can just use elimination straight up. 4 minus 2 will leave us with 2x. Negative y minus negative y is a 0 pair. Negative y subtract a negative is the same as negative y plus y. They will cancel out and form a 0 pair. Equals, now let's go back to grade 8, 24 minus negative 8. That's the same as 24 plus 8. 32 divided by 2, and we have x is equal to half of 32. 16 miles per hour. Oh, was this in kilometers or miles? Let me find my question in my book here. Uphill, kilometers. So this whole thing is in kilometers per hour, my bad. So this example, just, you get it. Switch, oh yeah, I've done it all right. Just here is where I was using miles instead of kilometers. So their usual average speed in theory is 16 kilometers per hour. This is how fast they're biking. And that makes sense. I mean, if it was 100 kilometers per hour, I would be very shocked that a bike club could travel that fast. If it was 1 kilometer an hour, I would also be shocked that any human beings could travel so slowly on a bicycle. So now I want to plug in 16 for my x in either one of these equations. I'm going to use this bottom one here because it is smaller, and smaller is easier. 2 times 16 plus 4 equals y. 2 times 20 equals y. 40 equals y. My solution to this problem is x, the speed, their usual speed, is 16 kilometers per hour, and y, the distance from Penticton to Chute Lake, is 40 kilometers. I'll box this as my final answer. All right, you guys have the test tomorrow, Wednesday. I will give you all of our period as well as the entirety of chapel tomorrow as well, so you have a bit of extra time, but that's all you've got. So practice this stuff, make sure you're quick at it, and I'll see you tomorrow if I'm not infirmed dead in my bed.